We are moving on with question 2 of June 2024, paper 1. Question 2.1. Consider the geometric series 4 plus 2 plus 1 plus a half, and that pattern continues. The first question is, does the series converge? So if it is a geometric series, we know that it has to have a common ratio of r. And convergence is about finding r, and if r is in between 1 and -1, then we can say the series converges. So let us find the constant ratio. So we'll have r is equals to the second term, which is 2 divided by 4, and that is a half. And let us just test our answer. So I take the third term, which is 1, and I divide that by 2, and I can see that the ratio is constant, and therefore the ratio is in between 1 and -1, so we can say that the series converges. The second question says, calculate the sum to infinity. So in order for us to have the sum to infinity, the series actually needs to converge. That is one of the prerequisites of the sum to infinity. But to answer the second question, we say the sum to infinity is equal to a over 1 minus r. And you can find this formula on your formula sheet. Now a is the first term, which is 4, and r is the ratio of a half. So when I substitute, I have 4 divided by 1 minus a half. And if I put this in my calculator, I have the sum to infinity is equal to 8. But remember, the sum to infinity cannot exist if the series does not converge. Question 2.2. Given the sigma notation with the lower limit of p equals to k to the upper limit of 10, and we're taking the sum of 3 to the power of p minus 1 is equal to 29,520. Calculate the value of k. So we'll start by finding the first few terms in this series. So I'll substitute p with k. So the first term would be 3 to the power of k minus 1. And I'll add it to the second term, which is 3 to the power of k plus 1 minus 1. Because the first term in the series is k, the term after k would be k plus 1. So that'll be the second term. And the third term would be k plus 2, and the fourth term k plus 3, and so on. So the third term we'll have 3 to the power of k plus 2 minus 1. And our fourth term would be 3 to the power of k plus 3 minus 1. So can you see, every time that I replace k, for the next term I simply add 1. And this continues all the way up until our last term of 10. So if I simplify this, I have 3 to the power of k minus 1 plus 3 to the power of k plus 3 to the power of k plus 1 plus 3 to the power of k plus 2. And this pattern continues. Now, I know that this is a geometric sequence, a geometric series, because we are raising it to the power of something. So that means we have a constant ratio. So to find the constant ratio, I'll have r is equal to 3 to the power of k divided by 3 to the power of k minus 1. And if I simplify this, I have 3 to the power of k minus 1. So remember, I'm using my laws of exponents where I subtract the exponents from each other. So that becomes 3 to the power of k minus k plus 1, which is simply 3 to the power of 1, or 3. So our constant ratio between terms would be 3. Next, because I want to calculate k, and I am given the result of the sigma notation, I know that this result is the result of the sum of the series. So it's Sn. So I want to find how many terms are in this pattern. So we have Sn. We are looking for the number of terms n. So in sigma notation, the number of terms would be the top value minus the bottom value plus 1. So it will be 10 minus k plus 1, and that becomes 11 minus k. So our number of terms would be 11 minus k. So I have an r value. I have a first term, which would be a, and I have an n value. That allows me to find Sn. So because this is a geometric series, I look at my formula sheet, and Sn is a times r to the power of n minus 1 over r minus 1. So you can find this on your formula sheet. Now we have Sn as 29,520. So let us substitute that. So it's 29,520. The a value is the first term, so it's 3 to the power of k minus 1. The r is 3, and the n value is 11 minus k. So we have r raised to the power of 11 minus k minus 1. And below the line, we have r, which is 3 minus 1. Now the mathematics looks a little bit daunting from here. So what we need to do is we need to solve for k from this equation. But can you see there's quite a little bit of work that needs to go into setting up the equation. We first need to find the first few terms of our geometric series, then establish what r is, and then find n. And now we're going to substitute it into Sn. So let us continue from here. 3 minus 1 is equals to 2. And I can get rid of this 2 by multiplying it with 29,520. And that simplifies to 59,040, which is equals to 3 to the power of k minus 1 times 3 to the power of 11 minus k minus 1. Now, I'm going to get rid of this bracket because there's nothing else for me to do, so I need to multiply out. So let's do that quickly. We have 59,040 is equals to 3 times k minus 1 plus 11 minus k minus 1 times 3 to the power of k minus 1. So what I'm doing is I'm multiplying 3 to the power of k minus 1 with the first term. And because the bases are the same, I add the exponents together. And for the second term, I simply multiply negative 1 with 3 to the power of k minus 1. So if I simplify further, I have 3 to the power of 10 minus 3 to the power of k minus 1. So can you see that in the first term here, k minus k would become 0, so I'm left with 3 to the power of 10. Now there are different ways to approach this. You can, if you want to, take 3 to the power of 10, leave it on this side, move 3 to the power of k minus 1 to the right-hand side. So let's do that. And I have 3 to the power of 10, and I subtract 59,040 from that. And when I use my calculator, I get 3 to the power of 10 minus 59,040 is equal to 9. And now it's pretty simple. I can rewrite 9 as 3 to the power of 2, and I have 3 to the power of k minus 1 on the left. So therefore, k minus 1 is equals to 2, and therefore k would be equal to 3. So like I said, setting up the equation is a little bit daunting, and from there, you need to just go through it methodically. So we need to get rid of the denominator by multiplying, then get rid of the brackets by multiplying out. Then you're left with two terms. So what I'm doing is I'm taking the term with k to the left and the term with numbers to the right. Then I simplify using my calculator, and from here on out it's pretty simple to solve. We want to write the bases both as 3, and therefore we can solve for k. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.